Hello all. Today I would like to present about my AI powered semantic function retrieval engine. In this video I will explain my project on the working of this engine that allows users to search through hundreds of functions using plain English instead of manually browsing documentation and the utility functions. The system extracts the metadata. One second, I'll show you. The system extracts the metadata first from the available functions, and it contains the functions and generates a vector embeddings using that. And we are using the company's uh, API, and we are updating the embeddings, and we take the user query and we create an embedding of that, and we create a semantic search using the two embeddings, and with that result we give a similarity score using a cosine similarity, and then we return the top 3 matches. In fact, we return the top 6 matches in a hierarchy from descending order. In that we select the top 3 and we return all the information that is required, like description, input, output, alias. So the original functions consist of this. This is the utility functions place where we store all the functions available and their description. And this is where, let me show the UI part how it works. For example, and I click on enter. So this is the two function which is retrieving. It is retrieving me, and as you can see, the correct answer is this one, the first top one. Reads an Excel or CSV file and converts all of its data into a JSON format. If I just take this, and if I want to retrieve that, only that part, and you can see here that node is available, so I can use this node in my workflow right now. So that's how this works. So the next one, I'll just use the next one, this one, and I click on enter. So these are the 3 functions which is retrieving, and from the text we can understand that the first one is the right one, to convert a knowledge graph context into string by combining formatted. Don't have it. The user does not need to have the complete knowledge on the functionality. Any part of the functionality is useful for semantic search. So let's look at the backend how it is working. So these are the current payload which is required. So this is the query text. We are using a variable in the front end to putting that variable here, and when I click on send, these are the top 3 which matches coming. But in this situation, the top 3, the second one is the right one actually. So as a user, the user can make an informed decision on what exactly to which function to use, which function to actually use. So that's how this project is all about. So I hope you like this uh, project. Thank you. Also, let's quickly go over the architecture on how it is working. Before we even go to the user side, first we take a JSON file, the output. Uh, this JSON file uh, is the family of the functions. This is the JSON file we are talking about. From this JSON file, we extract only the descriptions of that, from here, the descriptions, and we create an embeddings of only that part using this function. Use this function to create an embedding, and then we store those embeddings in the server. After that, when a user asks a question, we generating embedding of the user, and we do a semantic search of that, a cosine similarity, and we retrieve the cosine similarity, and we take the top 6 first, just to be in case, and then in the descending order of uh, similarity, and then we retrieve only the top three of those, and then we require the metadata. Remove, we fetch in all the metadata. For example, we use only this part for the semantic search. But when this is the correct, when we get to know that this is the correct answer, we want to retrieve this whole thing, the whole JSON. So that's what we are using for. So after best match, we return the top three functions, or else we ask the LLM to generate a new standalone